Hi, welcome to PhysChem with Liz. I'm Liz and this is the third video in the NMR series, and this video will be on splitting. So splitting is something that occurs in proton NMR spectra, and it happens due to a phenomenon called spin-spin coupling, which describes the magnetic interactions between neighbouring non-equivalent protons. Now, if you're not sure what non-equivalent means, you can check out my video on chemical equivalency. In this video, I'm going to show you how to apply the n+1 rule. The n+1 rule states that for a proton with n number of protons attached to an adjacent carbon atom, the number of subpeaks is in a splitting pattern equal to n+1. Now, I've drawn out some examples here, and I've kept some of these the same as the previous video on chemical environments to show you the link between these two things. So each of these red brackets shows one proton environment, and the number of protons in this proton environment can help us predict, using the n+1 rule, how many subpeaks our signal is going to be split into. So this first example, we have a molecule called butan-2-one. It's a ketone. We've got 3 different proton environments. So starting from left to right, this CH3 is next to a carbon with no protons attached. So we say this has no adjacent protons because there's nothing this side of the CH3 and there's no protons this side. So n equals 0. There's no protons next door to that CH3. Then applying n+1, 0 plus 1 obviously equals 1. That means the CH3 here will give rise to one signal, which we call a singlet on the NMR spectrum. Moving over here to the CH2, this is next to 3 protons. So we say it has 3 adjacent protons. So n equals 3. Apply the n+1 rule. 3 plus 1 is 4. So this CH2 is responsible for this quartet. It's split into 4. And then here we have another CH3, but it's different to this one because its neighbour is a CH2. So n equals 2, it's next to 2 protons. 2 plus 1 is 3. Therefore this CH3 here splits into a triplet. In this second example, we have a molecule of ethanol. You can see the 3 different proton environments in this molecule. So here we've got the OH proton, which is next to 0 neighbouring protons. So n equals 0, applying the n+1 rule, 0 plus 1 gives 1. So that alcohol proton gives rise to this singlet here. Moving on to the next protons, the next proton environment, we have a CH2. These are next to 3 adjacent protons on the CH3. So n equals 3, 3 plus 1 equals 4. This CH2 is responsible for this quartet. Now, we never have multiplets by themselves because this CH2 and this CH3, they are responsible for splitting each other. And lastly, we've got the CH3 protons. They're next to 2 protons, so they have 2 adjacent protons. n equals 2, 2 plus 1 equals 3. Therefore, that CH3 is responsible for this triplet. Now, in our final example, we have a molecule called diethyl ether. This is a symmetrical molecule, which means it has less chemical environments than it might otherwise. And I used this example in my previous video on chemical equivalency to illustrate that. So here, on this proton NMR spectrum, we're given some extra information. In the exam, you might be given numbers underneath the spectrum, or you might be given a squiggly line and a number above some of the peaks. This is called integration, and it refers to the area under the curve, which is equal to the number of protons responsible for that signal. Now you can see we've got two proton environments. These two are one environment, these protons are equivalent, and these are one environment as well. So I've called them A and B, they're the two environments. So for environment B, each CH3 is next to two protons. So even though it's next to 4 altogether, we say it's next to 2, apply the n+1 rule, 2 + 1 is 3, and this CH3 is responsible for this triplet here. Now we're given extra information, the integration, which says this triplet is worth 6, so it counts for 2 CH3 groups. So it counts for both of these. Then likewise with this CH2, it's next to 3 protons, none on this side. So 3 + 1 is 4, we get a quartet, its integration is 4 for the CH2, therefore it's both CH2s which are contributing to that quartet. That was quite a quick summary tutorial on splitting and the n+1 rule. I hope you found that helpful. If you did, please like and subscribe. If you've got any questions or you've got any exam questions on NMR that you're struggling with, please email my Gmail or comment below and I will respond. Have a nice day. Thanks for watching. Bye.